Hello dear students, let's see this question which is from 2024 October November paper 41 9709 mechanics paper from mathematics. And here we have a slope. As you can see, this is the slope. On this slope we have a ball. Okay, that ball is held at rest because of this P force. Okay, that P force is completely horizontal, and if I have this as theta, we know that this is also theta, and this plane is a rough plane. That means friction will also be acting. If the ball is going down, the friction will be up. If the ball is going up, the friction will be down. And the coefficient of friction they have given as 0.15 in the question, and the theta is sine theta is 7/25, and theta will be sine inverse of 7/25, so which is coming to be 16.23 degrees, approximately 16.23 degrees we are getting, 16.26 to be precise we are getting. And this is having a weight of 2 newtons, which is towards down. So we have to find the least possible value of this P. Okay, so I have enlarged diagram here. Okay, so that we can first draw a free body diagram for this one. So first, if I say that I have a force, okay, of 12 newtons towards down. Okay, this will be the component of that one component will be 12 sine theta here, and another component will be 12 cos theta here, parallel and perpendicular to the plane respectively. And here I have P, so one component of P will be along the plane. Okay, so that will be P cos theta, because this value, this is theta, and other one will be like this, which is P sine theta. So the ball is actually pressed in vertical direction, or perpendicular to the plane, by P sine theta, and also it has its own weight component, that is 12 cos theta. So in written, the normal reaction will be upward direction. In upward direction, that is equal to P sine theta plus 12 cos theta. P sine theta plus 12 cos theta. So I can write that N is equals to P sine theta plus 12 cos theta. 12 cos theta. Yeah, and also friction will be there because there is a rough plane. So friction will be in this way. That will be equal to mu times N. So N is given, mu value is given. So we have to just equate and find. Now the ball is at rest. So the vertical and horizontal forces we have to equate. First, we'll calculate for N, which is equal to P sine theta plus P sine theta plus 12 cos theta. So that will be equal to P sine theta value they have been given in the question itself, that is 7/25 plus 12 cos theta, theta value I said that is 16.26 degrees. So if I calculate it, okay, I'll be getting 12 cos of 16.26 is coming as 11.52. So this is actually 11.52, and 7/25, that will be equal to 0.28p. So 0.28p. So now if I want to find the friction, so friction is basically mu times N. So mu is 0.15, so 0.15, and the N value just now we have got, that is 0.28p plus 11.52. So if I multiply this inside, so this F is actually frictional force. Okay, this is actually a frictional force. Okay, so if I multiply that inside, 0.15 times 0.28, so that is coming to be 0.042p plus 0.15 times 11.52, which is coming as 1.728. 1.728. Okay, now this is the friction. Okay, so I can write FR for that. Okay, so forward force is 12 sine theta, and the backward forces, okay, down the plane is 12 sine theta, up the plane is FR plus P cos theta. So I can write that. So 12 sine theta is equals to FR plus P cos theta. So sine theta, we already know it's 7 by 25. Given in the question, FR is 0.042p plus 1.728 plus P cos theta. So cos of 16.26. Okay, so if I find cos of 16.26, I'm getting the value of 0.96. Okay, so 0.96. So let me write here. Then I have to calculate for this one. It will be 0.96p plus 1.728, that is equal to 0.042p, and 12 into 7 divided by 25 is giving me the value of 3.36. 3.36. So now if I calculate, okay, the p value, okay, I'll be getting us the p value will be getting us 1.63. 1.63. So this is the minimum value of p we have to exert so that the block should remain at rest. Hope this explanation is helpful for you in understanding this question. Thank you, students.